Okay, so this is a repeat of a lecture that was produced on Friday at 10 PM GMT. One of the first technical lectures that we did on game design at CC University. I'm just going to be talking you through it because the actual lecture was an hour long, and so we want to see if we can trim this down to a 15-minute tutorial. So, the lecture was showing us how to make the very first game in this course, and the game that we're looking at making is Breakout. So if you're not familiar with Breakout as it is, essentially the game is about controlling a paddle at the bottom of the screen, and the paddle essentially just bounces a ball that hits bricks, coloured bricks off the screen. The idea is to clear the screen of all the bricks. In the first part of the lecture, we managed to get this far. So you can see in this part of the game we have the paddle at the bottom of the screen, which is able to move from left to right, not exceeding the bounds of the window, like that. And we have the ball that bounces. It bounces off all sides of the screen, it bounces off the bat, and you can see it will just change its direction whenever it bounces off of something. And if it falls beneath the screen, then the game is over. Okay, so it's a very simple, very basic start, but we can talk a lot about some of the different theories and stuff that we have to in this part of the game, so there's a lot to talk about here. Alright, so the very first thing we should do before actually starting to build the game from scratch and jumping right in, we should actually think about what the game requires, and so we'll just think about the plan and how we're going to actually physically design this game. So there's a few things we're going to require. In Breakout, there are three main parts in the game. There's the bat, there's the ball, and there's the brick wall, the three major components. So as part of the game logic, you can see we're going to have to make sure that we're constantly updating these with input and things like that, handling the ball and the wall itself. So features we're going to require user input, we're going to require auto updating the ball, we're also going to require sort of things for velocity, movement, and draw code as well. So the first thing I suggest that we look at in designing this game is looking at just creating the bat and getting that started, because that's a good place to start. So the bat requires a few things. It requires an X position and a Y position. It's going to require a width, which specifies how large the bat is. It's also going to require two different methods, an update method which handles key events, so when the user inputs a key you can move the bat, and a draw method which just draws the bat on the screen. Probably a good place to start is to just get that bat working. In addition to that, our overall game structure is also going to require a main game loop that handles all drawing and all updates, so handling game timers and user input. Those are the main things that I think we're going to be requiring just to have a look at this. So we'll start with the bat. As you can see, I've structured the bat, the ball, and the wall in a way that looks as though they're particular objects in the game that have certain attributes. So that means we're going to be using tables to define them and to use them. So let's get started on the ball first. So we're going to go and turn this, as I say before, into a table. So as I mentioned before, I'm going to require an X position and a Y position. So we're going to go X pos, Y pos is equal to, and we're just going to set this to perhaps the width of the screen divided by 2, just the center, and right above the top of the screen. So width on 2 and height minus 1. Now I have to specify at the top of the screen, and this is always a good thing to do, is local w, h is equal to turn.getSize. I haven't made ball local because it's going to require access in a few different places, so it might be a safe idea to just keep that one as a global one. We can always change it back later if we need to. Alright, might be wise actually to do it like this. That's actually a little bit ambiguous otherwise. Okay, so we require an X pos and a Y pos. We'll need a width, which I'm going to set to just a simple, just 5 characters wide. I think it's probably large enough. Looks about right. They're also going to require a draw and an update. Now, in my tables tutorial, I talked a bit about being able to pass things through as though they're an object, and there's a really neat thing we can do to treat these as though they're objects in an OOP sort of circumstance. If we want to make our update function work, we'll require a reference to the ball table as well. So instead of passing that through, we actually pass it through as a parameter, which we're going to call self. This is similar to like the this keyword, if you're familiar with that in Java. So that works quite nicely too. Okay, I'm sorry, I've written ball here, I actually meant that. Apologies. Alright, so we'll start with the update method here. So update is going to be equal to function self. Okay. Firing through this a little bit quickly, but that's alright. So, in our update method, essentially we want to be able to handle user input. Now, I mentioned beforehand that to do this, we're going to require a key event to happen. Now, I could have inside this part of the update method, but I don't recommend that because it means that we can't handle game timers elsewhere, and we'll need timers to be able to specify things like when the ball has to move or when other things in the game have to update. So having a pull event inside an update method for an individual object is a bad idea. We should have a global event that then passes information to the bat directly. So we'll actually add that as a parameter. So we're going to go self key, and this will be essentially the key event that's been passed through if the game has been successfully run. So we're just going to go. This is quite simple. We're just going to go if key is equal to keys.left. So this is using the keys API to make sure we're pressing the left key. That's our left key. Then we can just go. We're just going to go xpos. We're going to go self.xpos because this is of course within the xpos thing. As I mentioned beforehand, this is essentially a reference to the X position of the bat here. So whenever we want to access that, we can't just go bat. You can go bat.xpos, but that's a bit messier. So it's much cleaner to just go self. That way you're just referencing whatever's been passed through. In this case, it's going to be bat. So that's just a nice feature you can use here. I'll show you how that works a bit later on. But essentially, when we run this, it'll be sort of run like a little bit like this: bat.update bat key event. Something like that is how that would be run. Although I'll explain a bit more about that in just a moment. So we have the self.xpos here. And we're going to be setting that to self.xpos -1. Is that enough? Probably not, because you can see when the bat's moving left or right, the issue is here, of course, that if we get past the left side of the screen, it will just keep on going. So we want to be able to sort of bound that. So we're going to say and xpos self.xpos gets that habit is greater than 1. That should be fine. Alright, keys equal to keys.right. So same case here, we have to say self.xpos is less than. In this case, it's actually going to be self is going to be less than the width of the screen minus the width of the bat. So that's self.width plus 1. That should work there nicely. So we're just going to go self.xpos equals self.xpos plus 1. So when we press the left key, it's going to be decreasing the x position by 1, and when we press the right key, it's going to be increasing the x position by 1 as well. Cool. So, goodish start there, which is alright. We'll just do the draw next. Like I say, I want to do this out quickly so we have something to look at. So we're going to go draw is equal to function. Again, you pass through self because it requires its own information. And draw is very easy. It's just going to be term.set cursor pos to xpos ypos. Term.set background color to colors.white. So we have a nice white bat, and then just term.right. We want to essentially specify that we want the bat to be as big as it is wide. So if you can think that should be 5 characters, we'd go 1, 2, 3, 4, 5 like that, and that would be okay. But if we change that width to 3, we'd have to change this as well. So what we can do is go string.rep, which literally means string.repeat the character of a single space width number of times. There we are. And that will mean that they'll actually create a string that is 5 spaces big, because the width is 5. If it was 2 spaces, it would be 10 spaces wide, and so on and so forth. Once again, because I'm forgetting, self.xpos and self.ypos are pivotal here. That's absolutely necessary. So that's a good start. So let's just quickly test to make sure the draw function is working alright for the moment. So we're just going to go bat.draw bat. And that looks a bit silly, because we're passing the table in through the bat thing itself as well. I think this looks silly, and apparently the inventors of Lua thought so as well, so they have a special bit of syntax which means the same thing, and that is bat:draw. Now what this literally means, don't get confused by it, it means that if a function is being contained within a table, and you use the colon interface, it simply means that the table is being passed as the first parameter in your function. So in this case here, it means that bat is being passed through as the first parameter in bat. So for example, if we're going to call update, something like, you know, bat update bat keys.left. That's bat.update. Essentially, if we go bat update like this, using the colon this time as opposed to the dot, we can just go keys.left, because as I said, the first parameter here, which is self, is actually being passed through with bat. So that means we just have to pass in the second parameter, which in this case is equal to keys. So just a nice bit of syntactic sugaring to help you out there. And just to make sure we can actually see what's happening here, we're just going to go term.clear, bat draw, and then just os.pull event key, and then shell.run clear. and it'll be all white, but oh, who cares? Alright, we'll just clear that out. Alright, that'll be fine, just to test it and to give us an idea. So let's go to Breakout now. Okay, and we've got a paddle in the middle of the screen there, which is looking pretty good, so that's nice. Just to make sure it's working okay, just go back to Edit, Breakout, and let's just change that now so that the XPOS is equal to something like 10. Looking good, excellent, okay. So we are making progress, which is very nice. Okay, so we have the update function and the draw function working nicely. So let's actually get the code so we can actually start testing the update function. So the way we're going to do that is we have to add a new, what I refer to as the main game loop. So we're going to call this function game loop. It's a strange name for a thing, but that's okay. And this game loop has to do a few things. First off, it has to sort of run as long as the game is running. So I like to have a while true loop in there. And we're just going to have a local function here, local parameter rather, called running. To true, and this means whether or not the application is running. So if this is set to false, the application should stop. So if anywhere in the program, if you want to stop the game, just turn that to false, and then the game should just stop. That's the idea behind it. And of course, that's very easy to do. We just go running. There we are. And you'll just have to finish off the rest of the code after it's been called, and then when it goes back to start the loop again, that's game over. So nice, easy way of ending the game when you're ready to stop it. So we just need to have game loop being called down here, which is fine. So that way that's going to be called. So what we're going to want to do in this case here is we're going to want to draw the bat each time. We're going to want to update the bat each time. Now we could go inside the loop, but this seems a bit cumbersome because as a consequence you should recognize that we're going to have to update the ball too, and the bricks too if we need to, and they all need to be drawn too, so it's actually better to have individual functions for those things as well. So it's a good idea in game design to have everything compartmentalized based on its categorization. So if we're going to have a lot of things drawing at one period of time, it should happen all at once. You shouldn't be drawing bits and pieces here and there. It should all be drawn in one big call, and that's our draw function. And when update is being done, the updating should not be done piece by piece, it should be done in one big go. So we should have a function update game, like that. I'm just using the prefix game, the suffix game there because we use draw and update here, and that's a bit confusing otherwise. So, alright, so we've got that going nicely. So let's actually draw the game. In this case, it's just going to be bat draw, very easy. So we can just have draw game here, which is nice. We should probably have a just to clear the background and just a turn.clear to get that displayed. This is a bit inefficient, but we'll talk about optimization in later lectures, that's okay. Let's do the update game next. So in our update game, we're going to be essentially calling this update method. Now this requires a key, as we saw beforehand, so what we're going to do is we're going to go local id p1, that refers to parameter 1, it's going to be equal to os.pullEvent. And we're not going to specify, because it might need timers later, so for the moment we're just going to keep it generic. We're going to say if id is equal to key, then we know that we want to pass the key through to our bat. But just one thing before we do that, just so we can quit out of a game easily, if p1 is equal to keys.q, then running is equal to false end. Now what this means is if the player hits the q key, it means I want to quit the game. They say, no, that's all, I've had game over. And what this will do is, like you can see, it'll just get out of update game, which should be in here. And running will fail, so that means it'll just quit the game. So that's just a nice, easy way to get out of the game very quickly. And it's got to just have like a, I don't know, clear down here somewhere, just to keep that nice and clean and stuff. But yeah, so we'll go from there. So we've got keys.q happening here, so let's move on now to looking at any other sort of input, and any other sort of input we want to feed directly to our bat. So we're going to go update bat, using that notation again, and this time passing through p1 as our only variable, because that variable is the key we want to update. And you can see when it's passing through into here, that will then check to see if it's keys.left or keys.right. So the update is done inside the bat rather than being done elsewhere. So it's sort of a nice, clean way of doing this. And as a consequence, that should sort of run nicely. So let's give that a try and see if there's any problems. And as you can see, we can now move our bat left and right using the left and right arrow keys. So you should also see that if you hit the side of the screen, that's actually still going a little bit too far, and I'll explain to you why that's the case in a second. And this side, that's going just far. That's good. Alright, so let's see why that's going too far, because it should be working perfectly fine, and it's not. We can hit Q. Yeah, I thought that might happen. To solve that problem where the Q appears at the end, and also that problem where the screen is white, just turn.set background color to to colors.black and sleep for 0.01, and that'll just get rid of that extra event which is being passed through and any opposite type event in the OS. Okay, so that's looking fine. So we've got our bat happening here, and the problem is it was going too far. The reason is we're dividing by 2 here. This was the reason that Laser Blast wasn't working, if any of you are curious about that. Exactly the same issue, is that this is a decimal number. 51 divided by 2 is actually equal to 25.5, not 25 even. So when it hits this thing here, greater than 1, it'll actually come up as 1.5, so it will still allow that movement into 0.5, which will actually equate on the screen as 0. So that's no good. So it actually has to be math.floor width on 2. And that will essentially just remove the decimal point. So if it's 2.5, it'll just become 2. It means goes to the round down from any decimal number to the nearest natural number. If you go math.ceil, it means math.ceiling, and it does the opposite thing. So it goes up 1 number. So if it's 2.5, it'll go to 3. No matter what in that instance there. So now if we go breakout, we should see the paddle stopping at the right point there, and it should be doing the same on the other side, which it does. Perfect. Alright, that's looking good. It's looking really good. Alright, so, now that we've got that going, let's have a look at the ball, which is the next part here. So, we'll just go back to our plan and have a look at it here. So what is our ball going to require? It's going to be very similar to our bat in a lot of ways. So it's going to require an X position and a Y position. It's also going to require... It's not going to require width or height, and the reason for that is because I'm just going to have my ball as 1 pixel, just a little 1 by 1 pixel, so width and height doesn't matter in this case, but what does matter is where the ball is moving. Now there are a lot of different ways we can do this, and the most common way would be use a vector, which specifies movement. There are reasons why I'm worried about using a vector, but for the moment we're going to go with one sort of similar to that, so we're going to go with xvel and yvel. This refers to the velocity in the x and y dimensions, or rather the speed in the x and the y dimensions rather than the velocity. So if xvel, for example, is equal to -1, it means it is moving by -1 each time it's being updated, which is very good. So we're going to go with that, xvel and yvel, and we'll also have in this code our update, which is going to require nothing because it's updated automatically, and it's also going to have a draw as well. So that's looking good. Now this is going to change the way things work a bit, because our ball is not updating with key events, it's updating with timer events, so we need to have a general timer that manages its movement. For that we need 2 things. First off, we need a refresh rate, which specifies how many times per second our game is getting updated. So we're going to call this our refresh rate. Don't worry, this is a bit complicated, but we'll get to it. I'm just going to set it 0.15. That means every 0.15 seconds we'll run another update bit of code. And then we just need to have a timer, which we're going to call local GTID is equal to os.start timer refresh rate. Again, I'll come back to that in just a moment. We'll talk about that in a bit more detail, but for the second, we'll need it for the ball. So let's get started on the ball. Let's get started on the easier stuff. So we're going to go a new table, which we have here. And in this table, we're going to require those things I specified beforehand. So we need the xpos, which is going to be equal to, let's just set that to the same thing we had beforehand, which is just floor w on 2. That's perfectly fine. So just above the bat. ypos would just specify as being, let's just make that math.floor h on 2. That's easy. It doesn't need a width nor height, but requires a velocity. So the velocity we're going to set to xvel, and we're just going to set that for the moment to -1. So it's moving to the left, and yvel we'll set to 1, which means moving downwards. Remember, in the computerized Cartesian coordinates, the positive dimension on y velocity is always downwards. The top left corner is your origin. Just remember that, so that's important. Alright, we'll go there as well. Now we have to write those update methods. So we're going to go update is equal to function self, which just requires self. We don't require key for this one, and we're going to require draw as well. So we'll make that up to... The draw is the first part. We'll do that because it's easiest. It's just, again, it's just turn.set cursor pos to self.xpos, self.ypos. We've done this already, so just simply specify the color and draw. Okay, easy. So that's looking good. And update, which is going to be a little bit more complicated, so we have to talk about this one a bit, because this is where the core of the logic of the game goes. Essentially, when the ball's being updated, we're going to specify that we want to increase its movement by these various dimensions, but it means we're also going to have to handle what happens when the ball collides with stuff. At the moment, there are 4 things that the ball can collide with. There are each of these 3 walls, and there's the paddle. If it hits the 4th wall, the bottom one down here, we have to check that as well, because that means game over at the moment. It just means that the game's stopping. Later, we'll have things like lives, but for the second, we're just going to keep it simple, so we're going to make that our game over area. So to do all of that, it's a fairly biggish job. So essentially, in our code, we're going to have something like this. Let's think for a second here. We want our ball to essentially move to that new position. So what we're going to do, yeah, we're just going to move it flat out to start with. So we're going to go self.xpos is equal to self.xpos plus xvel. Self.ypos is equal to self.ypos plus yvel. So that way it's just going to flat out move to begin with. What we should do now though is consider the fact that it is now facing a collision. So I'm going to do like a post-collision test to say if my next move will be a collision, I should change my velocity. And it's pretty easy to change my velocity. Like for example, if I've hit this left wall and I'm moving -1, I just need to change so I'm going to +1, so that way he'll start bouncing in that direction. So if he's going up like this, I just change that from -1 to 1, and now he'll go like that. If I hit the top wall like that, I'm going 1, I just change that to -1, and the same thing happens. I go back down again, even though I keep those dimensions. That's the cool thing about it, which we can use. So let's look at those 3 collisions first. Let's look at the wall collisions and get those going. So I want to say that if xvel, or rather if xpos is equal to 1, that way it's on the left side of the wall here, we're going to see whether or not it's moving in the right direction. So and xvel is equal to -1. That means not only is it against the wall, but it's also moving in the direction of the wall. It means it can't go any farther. If we update that again, it'll become 0, and that'll be off the screen. That's bad. So what we want to do is just go... now remember the selfs again. This is something I often forget, and it often brings me to grief. So self.xvel is equal to self.xvel multiplied by -1, and that's our little trick there that we use, and that will just flip the direction of the thing. Then we can check the other x directions, see if the self.xpos is equal to the width of the screen and self.xvel is equal to 1. Really, you can have this in one big loop to say we're not one big condition where all 4, either of those conditions can be met, and the result is the same. So that could save you a bit of code, but it doesn't really matter. So xvel multiplied by -1, just to get it sort of out there and done. The next thing we have to check with is the y. Now we can't do this as an else if, because if we do, it means that if this one equates to true, it will skip over it, and that way the ball, if it hits in that corner, which it might do, it will just keep flying away. That's no good. So also I've used equals here. I should probably make that equals less than or equals to, and this should be greater than or equals to, in case the ball does go one step too far. It just catches that behavior. Also, if that velocity is greater than 1, then that's also an issue. So, all right. So let's do this now. We're going to go if self.ypos, so we just do the ypos next, is less than or equal to -1, and self.yvel is equal to -1. So the ball has hit the top and it's moving upwards. Then we just need to flip the direction. Alright, self.yvel is equal to self.yvel multiplied by -1. And the real trick here is if self.ypos is greater than or equal to h, and self.yvel is equal to 1, then it's hit the bottom. Now, we don't just flip the direction in this case. In this case, we actually have to end the game, which is very easy to do. It's just running as if to false. Okay, nice and simple. And that will just end the game for us, which is quite pleasant. So we can do that. So that's looking pretty good. That's handling bouncing around the map pretty well. So we can probably test that just to start with and see how it's going. So we need to update our game now. Yes, no, we can't test right now because this update needs to be occurring in time. And that's where things get a bit trickier. So essentially we want this to be updating every now and again. In this case I've said I want it to be updating every 0.15 seconds. So to make our computer do that, we have to run a timer that's running every 0.15 seconds. And when that timer expires, we start a new one and we refresh the game. And that means we update the ball's position and things. And that's being done with this thing here, GTID. This GTID is a number that's returned by os.startTime to indicate this is the timer that I specified to refresh the game. It's the variable. It will usually be a number like 50 or 200 or whatever the game decides to assign that ID. It's always unique, so you never have to be afraid of that getting wrong or mixed up between applications. So that's quite nice. But yeah, that's what we'll need to update our game. So essentially what we can do is we can modify our update method in this part of the game here and go else if ID is equal to timer, and we want to check here as well. We want to make sure that the ID is the right one. So that is P1 is equal to GTID. Then we know that the timer that has just elapsed has been pulled as an event because timers throw what's called a timer event, which is here, which has the right ID, which is passed through as the first parameter. Then we know we've just caught the gamer ID. So what we now want to do is now want to go ball update like that, and then we just want to set that ID to another timer. is equal to os.start timer refresh rate. If the game's moving too quickly or too slowly for you, you can just increase or decrease that refresh rate, so you can get it to 0.2 or 0.3 or whatever you like, really, and that will slow down or speed up the ball. There's a better way to do it than that if you want to do other things in case you want to do lots of updates, but for the second, it's perfectly fine, so we're going to stick with that for the second. So let's say we've got key, we've got timer, we're updating that nicely. Now we just need to make sure that the ball's being drawn, which at the moment it probably isn't, so we're just going to go ball draw in here as well, and that's it. So let's see if that's going to work for us. Oh no. Breakout line 14, nil and number. So we got a bit of the way, so let's see how far it got here. Aha, yes, so self dot. I mention it because I'm really chastising myself, because I make this mistake. I'm sure you guys will be much better at it, but still no good. Xpos rather than Xpox. There we are, and that's moving pretty quickly, and that worked nicely. So let's slow that down. That's a bit fast for me. We'll get that up to 0. In fact, let's actually. I might be able to catch him if I just change that Y velocity to -1, so he goes up first, hopefully. So that's moving pretty quickly, but you can see that's bouncing really nicely, and the game's working really well there. So yeah, that's looking really good. If we try the other wall, because that's testing the left wall quite well, let's just change the xvel to 1 to make sure that's working there too. If you want to, you can also change the bottom floor to actually bounce it if you really want to test this properly. We're not going to worry about that. The last thing we're going to worry about now is colliding with the bat, and that's probably the big thing as well. So we'll probably do this before we do the wall collisions, which is okay, and if it happens we can just return out. So how do we tell if it's colliding with the bat? Essentially my way of checking is once you've moved the ball, we should see if the bat is directly below it. So how we can do that is we can go if self.ypos is equal to bat.ypos -1, that is to say it's one step above it, then we know it's right above the bat. We can now check to see whether or not it's actually, if it's actually on, the bat it's on the right plane as the bat. We just need to make sure that the bat is in the right position. So essentially what we want to do to test that, we want to see if self.xpos is greater than or equal to bat.xpos. That means at least it's to the right side of the leftmost point of the bat. And self.xpos is less than or equal to bat.xpos plus bat.width -1. That is to say it is less than the rightmost point on the bat as well. So those are the three things we're checking there. To make sure it's on the right plane, which it is, checking to make sure it's on the right side of the bat, to the left, and the right side of the bat to the right. And if it fits within those two parameters, we know it's hit the bat in the center and it should bounce off. In that case, we just go self.yvel is equal to self.yvel multiplied by -1. That's it. So that's actually, let's see if it's bouncing. Again, that's moving a bit fast. I have to slow that down. And that's bouncing really nicely. Look at that. That's really good. So you can see that's now hitting the bat really well and just bouncing off that clean. Let's see if we can hit it in the corners. Might be a bit tricky. I'll give it a try. Nah, I missed it. Alright, now, you might be asking the question, why don't I use more complicated hitboxes and things for the bats? And the question is, do we really need to in this instance? I mean, as you can see, it's a very simple game. Got it right on there, which is really good. And so we can actually trim down a lot of the complexity just by having much simpler collision code, which is perfectly fine. That's why I recommend sort of looking for these little tricks and things to save yourself some time as well as to make the games a bit easier for you to program too. Cool. Alright. Listen, that'll do. So this is as far as we got in the first lecture. In next week's lecture, which will be next Friday, 10 PM GMT, I'll be talking you through looking at how to make the bricks at the top of the screen work and stuff like that. So yeah, we'll slowly build the game Breakout from the scratch and look at some cool teachers do with optimization and stuff like that as well. Cool. Alright. That'll do for me. Thanks very much for watching, and I hope to see you at the university soon.